All right, so in this lesson, we will use the triangle proportionality theorem. Use the triangle proportionality theorem to calculate unknown side lengths. So basically, we're going to use triangle proportionality to figure out like side lengths that we don't know, right? So before we do that, let's talk about the triangle proportionality theorem. So as you see, we have this triangle, this smaller triangle, BDE, BDE. I think I can do that a tiny bit better. BDE. And you see how this triangle is like inside of this triangle. But you see DE, let's back up a tiny bit, DE is parallel to AC. So this side of this small triangle is parallel to this side of the larger triangle. That means that that triangle BDE is going to be similar to triangle BAC. Triangle BAC. So triangle BDE is similar to triangle BAC. This is only true, they're only similar because DE is parallel to AC. Like if DE went like this, then obviously they want to be similar because they'd be like, they'd be different triangles, like obviously different triangles. So let's look at this. So we have DB is proportional. So remember, let's back up. If they are similar, if BDE is similar to BAC, that means they will be proportional. They will have a common scale factor in certain instances, like the relationships between the sides will be the same. So DB, it says DB, I should have gone the other way, goes to AB. So DB goes to AB. So small to large should be the same as B DB. So DB, I guess I should go EB, right? As EB is to CB. Okay? Let's do the next one. So DB is to EB. So DB is to EB. So DB is to EB. So the left side of the small triangle to the right side of the small triangle should be the same as or equivalent to AB to CB. AB. I can't even stop drawing triangle. AB is to CB. All right, let's try pink. So DB is to EB. Oh, okay, there's another one. Okay, so the small triangle, normally we just did AB and CB, but it's actually also this section that's left over, like AD and CE would also work. AD, EC. So 80 to C. Okay. And let's go to the next one. So DB again goes to 80. So DB goes to this little section that's left over, as EB goes to EC. CB. Wait, EB, CE. I gotta put it in the right order. Okay, and AD to AB. AB as CE is to CB. And lastly, AD goes with CE. Let's see, do I have any more of those? Yep. AD, CE, DB, EB. dB. Now let's just, I guess, change the color one more time. I think I ran out of colors. Yeah, dB. The point is, there's a lot of relationships in here, right? Like, chances are, if you think it's 1, it probably is 1. So, what is the length of x? So we have x. Okay, so let's do it one way. So we know that x to 15, x to 15 should be the same as 3 to 9, or is equivalent to the relationship of 3 to 9. So then we just have to solve for this. So what I'm going to do, there's a couple different ways you can do this. The way that some people do it is they cross multiply, but I'm going to do it one at a time. So I'm going to multiply both sides by 15. So this goes away. Well, I'll do it like this. I'll multiply both sides by 15. I should use a different color. Both sides by 15. So the whole point of doing this so that these go away. I end up with x. Oh, that's a little, it hides it a little too well. Okay, so then I end up with x equals 15 times 3 is 45. I can do this a little better. 45 over 9. So we get, oh man, trying to keep this coordinated, color coordinated the right way. Okay, there we go. So that should be 15 over 1, and then I will get 45 over 9, which ends up being x equals 5. Okay, now there are other relationships though, right? So I don't just have to go x to 15, 3 to 9. I could also write x to the whole thing, which would be x plus 15. And then 3 to the whole thing, which is 12. The reason I'm showing you both ways isn't because, like, I know you're going to choose the easier one, but that's the point, is that sometimes one will be easier, and I need you to be able to do both or experience both to figure out which one is easier. So here, oh man, okay, so we end up with this x plus 15 on the bottom. So what I'm going to do is I'm going to multiply both by x plus 15. Let's see. So when I multiply here, the whole point is that these go away. So I end up with x equals, and then I end up with x times 3 is 3x. 15 times 3 is 45. Oh, color coordinate again. 3x plus 45. Okay, and then we end up with, don't forget there's a 1, 12 times 1 is 12. Okay, so let's multiply both sides by 12 now. Yeah, that's, I guess, the only thing we can do. Well, I mean, we can do more, but it's the only thing that we can do that y'all will quickly understand. So we end up with 12x. Oh, let me draw this arrow first. So we end up with 12x equals 12 times 3x. Oh, I forgot, we don't have to do all this. Remember, the point of doing this is so that we can cross these out. So we end up with a 3x plus 45. And then, oh, that looks a little clunky. 3x plus 45. Now I will subtract 3x from both sides, and I get 9x equals 45. Once again, well, you'll see, divide by 9, and I get x equals 45 over 9, which is 5. Now, once again, it's not that this way is easier. It's that I'm showing you that there, oh, I went up too far, that there are lots of relationships. Oh, I think I meant to go there. All these relationships work. All of these relationships are valid. So no matter which one you use to find x or y or whatever, you'll end up with the same answer because all the relationships are true and like they go together, so to speak. Like one relationship doesn't make one other relationship not true. I mean, they all complement each other. So let's go